So a nice and warm welcome from this time mostly Munich. It's a beautiful sunny day in Bavaria. It's time for lunch, not for us, but hopefully for you. Maybe you've got some delicious food while you're listening to Olaf and us guys. Still some people coming in, but I think we can mainly start. Everybody, if you, hi Isabel. If you want to test out the chat function, feel free to call us, tell us where you're from. Friendly hi to everybody from myself, from Munich. Yeah, today's talk is going to be from Olaf, but before that, a little words from our partner, from IBM, and from us, from the organizational side, from ConSol. First of all, yes, please use the chat to ask questions. You can also use Q&A. Since we are recording this session, I will be your voice. I will tell Olaf if new questions come, if there's something in the discussion in the end. Then I will read your questions to him. And yeah, but if you know this discussion and our panels from last time, this time there will be not so much time for a discussion in the end. Because Olaf has 2 demos, and we know this might take some time. So we will see, but feel free to ask questions anytime. We will see when we come to answer them. Okay, great. Hello to Switzerland. So many people from Switzerland to Stuttgart. Yeah, I would like to introduce to you also from Switzerland, Sid from IBM. He's filling in for Marion today. He's from her team, and you will see her face on the slides again. So Sid, hi.
Hi there. All right, let me share my screen and hopefully that will work. Share presentation mode. Can you see the slides?
Yep. Yes, excellent.
Okay, so hi there from Winterthur, just outside of Zurich. My name is Sid Aurora, as you can see from the Zoom link. I'm standing in for Marion. We're in the same team, known in IBM as the hybrid cloud build team. Marion is on has the enviable task of being on vacation this week, so I'm jumping in for her. And I'd just like to give a short word introduction to IBM Developer. So IBM Developer is IBM's initiative to reach out to both our partners and developer ecosystems around topics such as hybrid cloud, data and AI, and all things open source. This is based on, you could say, 3 important pillars around code, around content, and around community. In terms of code, you can find tons of code patterns, starter kits, code snippets, all of it on developer.ibm.com. And I'll share the links to these after I'm done presenting. I'll put them in the chat. Most important, even more important than code, I would say, is content and community. All of our experts and advocates, developer advocates, are constantly creating videos, how-tos, tutorials, blog posts, and all of these you can also find on developer.ibm.com. And most important is our community. All our digital assets are accompanied by free live sessions, webinars such as this one, and most important, interactive hands-on workshops. The most recent local activities can be found on our meetup group, which is obviously in Corona world is moving in a hybrid online world back and forth. And you can find these all under meetup.com/IBM developers. So the link on the far left. I'd also like to mention our free digital developer conference that's coming up again, this time on September 21st. And there the focus will be strongly on hybrid cloud topics. And you can just follow the link developer.ibm.com/conferences to see agenda and also to register. In terms of other great examples of with our developers, we have a series for AI and data and AI. The link is here. We have one around application security and finally, one also around application modernization. And if you're an IBM partner, we welcome you together with ConSol. We are more than happy to engage on together on developing MVPs, minimal viable products, or to do a POC, everything related to content such as the one today around OpenShift and operators. We have the possibility also for you to get a free account to get started on the IBM Cloud if you haven't already done that. I will share a link for that as well for you to get quickly started. And I'll also share my contact details. And I think you'll get these slides afterwards as well, or they'll be in the replay. So you can contact myself or Marion when she's back from holiday. And with that, back to you, Olaf.
Yes, thanks, Sid. Olaf, we have the first question right away. Can you start with benefits of operators over Helm? I think you will cover that in your talk, right?
Yes, this is what I plan to do. So
excellent. Then with no further ado, let's start.
Where is Zoom? There is Zoom. Share screen, desktop one, share. Okay. Can you see my presentation?
Looks good, yes.
Great, perfect. So let's start with the operator development with Helm made easy. So before I go into the details, just a short description about myself. I'm working at ConSol in a team which is focused on OpenShift and Kubernetes. So we are setting up clusters for our clients, mainly at their side, if it's wanted, also in public clouds. I'm here in that, or my position in the team is more a bit dev oriented. So I'm coming into play when my colleagues have finished setting up the cluster. So I help the customers to build their application on cloud platforms, to see how they can move the container images to the cloud, to do the whole part with how to deploy at the cloud, how to make sure that it's resilient and so on. So my part is starting with day two, so to say. One small thing that I need to talk about a bit is about ConSol. So we're a bit older company. We are focusing mainly on software engineering and on operations. So if you want to know more about that, please feel free to look at our website or give us a shout. We will gladly help you out or give you some more information. Okay, so let's start with the agenda. So what I would like to talk about in this webinar is what are operators, also give an introduction what's different from operators than using plain Helm charts, for example. To talk a bit about why this is interesting for me as a DevOps engineer, because what I see so far, it's mainly used for operational parts, which I'm not so much concerned as a DevOps engineer, whether my cluster has the perfect storage attached or not. It's not my focus. The part that this talk is about is why to use Helm operators if you got other ways you could use, like Go, Ansible, or whatnot. And finally, also I would like to mention when not to use operators or Helm operators in specific. And finally, which is also part of the demo, how could I combine operators with GitOps? So the talks that Sebastian was doing about Flagger and Flux, how could I integrate something like an operator with Flux, or in my case, ArgoCD, to see what the benefits are, what the differences are, especially also why it makes sense to use a Helm operator and not use the Helm plugins for ArgoCD, for example. Okay, so much for the agenda. So let's start with what are operators. So the term operators comes from an article from Brandon Phillips, who was working for Chorus at that time. And he was putting together that the operators is the knowledge that a person or maybe an application has that you build into a container. So if you have a certain knowledge how to deploy an application, how to maintain that, how to make backups of that, usually it's not helpful if you do all the stuff, all the parts manually. So it would be great if you could automate that, and a way to do that, or principle, a pattern how to do that is with operators. And if we look at operators, they are very similar like normal control patterns that we have in Kubernetes. So operators are using a declared state, which describes how my application should, or framework or whatever, should be deployed into the Kubernetes cluster. Usually this declaration is done with custom resource definition. So you define your own custom resource. And this is what I will show later on, how we could do that, for example, for an Nginx stateful set, how we can define what we can provide as information for a stateful set, how you, maybe if we've got some time left, how we can set up rules, what the user can do or can't do, and also to provide some help. If this state or the CRD has been defined, an operator will watch that and watch all instances of it, so the custom resources, and will apply the information to the resources in the appropriate place. So in our case, or in the demo case, it will look at the definition of the Nginx stateful set and will make sure that all the stuff that needs to be run for the Nginx will run into the Kubernetes cluster in my defined namespace where I would like to have that. So that's the one way. Also, it makes sure that if something is missing, so if you, for example, delete something or change something, the operator will update or revert that changes with the original state that's intended. So there is no or less possibility that a user can modify the deployed application without the knowledge of the operator, or without the parts where the operator says, yeah, that part is fine, the other part, please don't touch. And to be able to communicate with the administrator or with the user who created the custom resource, we provide a state, or the operator provides a status. So this is usually the part in the custom resource. There is an attribute called status, and there you can see what the status of the deployment is, whether the application, the deployment was successful, whether it ran into an error, when an update occurred, or something like this, you can find there in the status field, and you can have a look what's happening there. So you always know in which state my operator is. So you've got the loop, which will check whether the declarative state or the desired state has changed. And also there is another loop which makes sure that the applied changes or the managed resources will stay in that way how they should be. Okay, so far for the operator. In coming back to the question regarding Helm charts, with Helm charts in general, what you would do is you install a Helm chart. So as an operator, or as a DevOps engineer or a software developer, you run a Helm chart, deploy your resources into a Kubernetes cluster, maybe do an update of the resource for a newer version, but that's it. So there is no way that there is a loop which will make sure that all the parts that you have installed with the Helm chart will be in sync with the desired state that you wanted to have when you try to install it. So yeah, So that's the biggest difference, is that the operator have a control loop which makes sure that the state is what you want to have, whereas an operator, it's more like a one-off operation which happens at the beginning or later if you do updates. Okay, so with operators, as much fun as it is to write it on your own, you can do that. You can write your own definition, how to set up the deployment with the operator, how to write, or you can write your own custom resource definition. But there are a couple of frameworks which will help you to build your operator. So you don't have to do that from scratch. The one that I will show later on is the operator framework, which is the CNCF project. There are a couple of other ones as well. So you've got COP for Python, you've got KubeBuilder, which is focused more or less on Go, and which is also embed, or which is also used in the operator framework for Go. But I will talk about that a bit later. You've got Meter Controller, and finally you've got also somebody who's writing an operator for Shell. So if you really want to do a bash hacking, for example, to create your own operator, feel free to do that. I prefer to use Helm or maybe Go. Okay, so let's talk a bit about the operator framework. The operator framework consists of 3 pillars. So the first one would be the operator SDK itself. So the software development kit for creating operators, to do updates, to build them, to test them, and so on. The second part is the operator lifecycle manager, which is something that you can install in a Kubernetes cluster, or it comes with OpenShift built in. So there is the operator lifecycle manager takes care that it's easier for the user to install operators, to provide information about what version of operators we are using, which channel, is this an alpha channel, is this a stable channel, and which will also take care about updating the operator itself. Because updating resources is one part, but to have the latest operator running, which will do, for example, updates in certain data, is something else. And finally, there is the part which is the operator hub, which is kind of coming from like Docker Hub. So it's a central repository where you can upload your operator definition, and then other people can use that in their Kubernetes or OpenShift cluster. OpenShift is there a bit special, so to say, and so far that it has a stricter policies regarding security. So basically what you can run on Kubernetes, you can run on OpenShift as well, as long as you not try to run containers as root and you don't want to give them privileges, which is not something that, or you can do that in OpenShift, but it's not something that you do out of the box. Coming back to the operator SDK, so we see here is that there are 3 languages frameworks supported. So the ones that we are talking about today will be the Helm operator, or Helm. So how you build operators based on Helm charts. The second part would be Ansible, and lastly Go, which is using the scaffolding for KubeBuilder. Ansible and Go are kind of, it's a flavor where you come from. So if you're more coming from the operation part, you might got in contact with Ansible, and this is a quite powerful framework. So you find modules for a lot of use cases that you could use to migrate data, to create OpenShift clusters, for example, till version 3. And similar is with Go. So if you are more from the dev part in the Kubernetes area, you might be familiar with Go. So there Go offers some very nice features to build operators around. And features is something that I would like to talk about now, because each of these languages will have different capabilities. So I don't know whether you have been to some Red Hat webinars or not, but if they talk about operators, you might see that picture here, where they show the capability level. And the idea behind that is that the functionality of an operator is depending a bit on the language or on the framework that it's using. So for Helm, it offers capabilities from the level 1 and 2, which means you can install resources, you can configure them. With level 2, it means you can also do an update of version, you can do patching. And this is really what the focus of Helm is about. Of course, you could do later on with some hooks and so on to do data migration as well. But the main focus from Helm, from my point of view, is really the focus on the resources and not so much on the data. With Ansible and Go, you've got more capabilities. You've got what they call full lifecycle support, which means that you, for example, enable your applications that they have backups, that they've got to restore, that you do application migration parts where you update data and so on. Level 4 gives you more details, insight into the applications that you deployed, so you can see metrics, you can do some log processing and do some workload analysis. And level 5 is more or less the top of it, so you can do automatic scaling, either horizontal or vertical. You can do some automatic configuration tuning and so on. So if somebody of you has an operator which is really doing that, not only saying, yeah, with Go it's possible, or with Ansible it's possible, but which really has some tuning of the configuration and also has some anomaly detection, please give me a shout. I later on give my email address or a Twitter handle so that you can send me a notification. And as you can see here, we've got Helm. And this is what we talk about regarding updating and installing and updating. So basically, it's up to you what you would like to use with the Operator SDK. From my point of view, coming back to Helm, it might be still a good idea to start with a Helm operator, even if it's only supporting level 1 and 2 and not the level 3 till 5. So I think one of the key features of the Helm operator is that Helm is it's very broadly used for packaging of Kubernetes applications. So if you search for a specific framework or a commercial version, it's very likely that you find a Helm chart which will allow you to install that application into your cluster, or which will do the updates and so on. So you will find a lot of framework, a lot of Helm charts which help you create your application, or which will help you create applications into your cluster. The second part is also that Helm is very easy to use. And yes, it can be long, but it's also easy to read. So there is not much, not so much functionality behind it. See basic principles like if else choices, you've got some while loops, you've got some replacement, you've got other commands so that you can, for example, limit the length of a text. You can encode it then with base 64 and write it in the secret. It's all in place, but the way how you do that is, it's really easy to understand. At least this is what my experience is. And the good part is it's something that you can use later on into more advanced operators. So if you start with a Helm operator and then later maybe move to Go operator, it doesn't mean that the work that you've done into the Helm operator is worthless? I would say no, not at all. Because do you really want to use, or do you really want to write every detail of a resource with Go to a Kubernetes cluster and specify that? Or would it be easier just to use the Helm internals to use Helm to deploy the resources and focus more on the parts where you really need that Go part to, for example, update this data or migrate data? So I would argue that it might still make sense later on to use, even in Go, operators, Helm charts for creating and updating resources. And finally, with Helm charts or with Helm operators, you define custom resources. So you define your own Kubernetes resources. You can define what the content is. You have a good way to document what attribute is having which feature, what it's causing when it's read, what it's doing. And also you can do a validation of it. So you can tell, okay, this is a replica, and replica is a number which can be going up to 10 or which has to be lower than 10, for example. So you've got some documentation, and this is something that you could do in Helm charts, but it's not that obvious for a user to see what can I do with that, what's easy to use. And if you use the operator lifecycle manager, it becomes even easier, because in OpenShift, for example, you got a GUI, which allows you to graphically just click together what you would like to have. So you can have the standards inputs for defining the number of replicas. You've got standard ways how to define the resources and limits for pods and containers. So it makes it a lot easier if you have CRDs which help you to for documentation and validation. And it's, at least from my part, a bit easier to read than a values file from an operator. So I have talked a lot about why to use, or why it makes sense to start with Helm operators. But there are certain use cases where I would say, no, don't use a Helm operator. So if you see, for example, that you not only manage resources in Kubernetes, but for some reason also need to interact with some external resources, this is something that you can't do with Helm charts. So because Helm charts are designed to update and create resources within a Kubernetes or OpenShift cluster, but not for external parts. You might find some hacks around it, but mainly, from my opinion, if you have an external resource like a load balancer, a database, or whatever that you need to configure, maybe it's worth to have a look at Ansible or Go operators, which will help you with that task. And also, coming back to that data part, if you have a very complex data setups that you need to do, so if you deploy an application which will pull data from multiple locations and will do a setup with this data that you get and write it to some database, or if you do have a complex application data migration going on between version 1 and version 1.1 and so on, if you change a lot of contents of tables, then the Go operator, the Helm operator might not be the first choice. So could be worthwhile to have a look at Go, whether this is a better suit for this scenario. In general, when not to use operators at all, could be if you just have one application deployed in development, test, and production. So typical scenarios that you have with GitOps, that you just want to deploy one application with a little different settings, then I would say it doesn't make sense. So if you have like multiple settings, think about maybe Helm as a Helm for creating and updating it. but otherwise I wouldn't use an operator for that. That's a bit overhead. And also, if you have an application which just infrequent gets updates, so it's not get like an update every once a month, so you get a new image, I am not sure whether you would run, whether it's necessary to have an operator running, which would make it a bit easier for you, or if it makes sense to come back to GitOps and see whether you can integrate it there, because Fluxer has some nice capabilities to update images in deployments, for example. Okay, so I've done a lot of talking. Now let's go to the demo part. But before I start with that, let's give a small introduction what I'm going to talk about. So the first demo will be about a Helm operator. So we take an Nginx stateful set that I created, and we will build an operator around it. And the Nginx just contains of the stateful set, config map for the configuration of the Nginx, a service, and a route. That's it. And we will wrap that into an operator just to give you an idea how easy it is to start building the operator if you have a Helm chart already running. So the second part is I will talk about how to set up resources or how to set up projects, like with namespaces, quotas, limit ranges, where you can define your admins based on a custom resource definition. And also there you can add some example application running in that new created namespace. The reason behind that is we had a lot of discussion with customers that they wanted to have a way to automate the way how to create namespaces. So in OpenShift, you might have like 100 or more namespaces for each customer, for each team separate. And you don't want to create them manually, adjust the quotas and so on. It would be good if you have a standard way how you can create them. And also for new customers, or new users, it's helpful to give them some guidelines, to show them an example application, say, hey, here, that's a good way how you can start, for example, with Node.js application. So you can see how this works, how OpenShift builds their image and how it's deployed and so on. And the reason also why I'm showing that is, of course, both ways is something that you could do with Helm charts. With Helm charts, you are able to create namespaces and so on. And you can also use them in conjunction with ArgoCD. So you use directly your Helm charts, the definition, and deploy that part, what the Helm chart is doing. Where I see the benefit is that the operator does a little abstraction of that Helm chart and provides you a cleaner interface or a leaner interface for specifying what you would like to do. So you've got your custom resource definition, and from my point of view, it's a bit easier to read, easier to validate, and you get less trouble with colleagues or admins who are saying this is not working how I intended. Okay, enough talk, let's see the demo. So let's switch to a terminal. Here I've got my clean and empty directory. I've got my Helm chart in a different directory, which is just called Nginx STS for stateful set. And as you can see here, it has a values file, like all Helm charts, config map, all the stuff that I mentioned before. So if I want to use that in an operator, to create an operator, what I usually do first is to create an environment variable, which contains a link to the image that I'm going to use for the operator. Here in my case, I use the key IO with a personal account. So let's define that one. And now let's build the operator. So let's see, yeah, it's still in the history. So what I'm doing here is using the Operator SDK. I'm telling it I would like to set up a new operator with the init command. With a plugin, I'm telling it I would like to use Helm as a language with group and domain. So parts here. I'm specifying for the CRD which values should be used in the API version. So that's going into the API version. I need, of course, to specify the location of my Helm chart and also a project name, which will be later on used into the OpenShift cluster for defining what the name of my project will be where this is deployed. So if I start with that and run it, fingers crossed that everything is working. Yeah, it looks fine to me. So it's creating the API, it's contacting the API, it's writing the manifest to a file, it's copied here the Helm chart, not created. And finally, we've got a warning telling us that all the resources or the role RBAC management for roles and role binding is something that you would need to have a look at. So if you have some not common resources, the scaffolding of the operator might overlook some resources, or it doesn't know all the resources. So there might be a gap that it's not really there, that you need to adjust the RBAC setting of it. And this is why we've got that warning. So far, this looks good. Let's have a look what happened here. So as you can see, a lot of files have been created, and basically it's split in two places. So you've got the configuration, which is heavily using customize for defining the resources. And into these resources, we have an example of our CRD that we are going to deploy. We've got a definition how to set up the deployment of the operator itself. We've got the RBAC settings. We've got some definition for Prometheus, how to create metrics. And last but not least, we've got samples, which is, this is an example, CRD custom resource that you can use to deploy your application after your operator is running. So you don't need to build it by your hand. You've got an example here. And you've got the scorecards. Scorecards is a test environment for setting or verifying that the configuration of the operator is correct. And you can also add additional tests for integration to see whether the mapping of the values from the CRD to your cluster is really working, or the configuration settings are really working like you intended, that all the correct properties are set. At the bottom, we can see we've got a Docker file for our Helm operator. We've got our Helm charts copied here, and we've got a make file, because all of the stuff that's happening, all the commands that I will now execute will be coming from a make file. And this is the way how to build your operator. But before we start, I need to do some update, because here we are at Visual Studio in the same directory, and we need to modify the deployment of the operator. Let's go here to Manager. So as you can see here, it's the deployment of the control manager in the namespace systems, which will be overwritten. These two parts will be overwritten. So that's really the deployment of the operator. And this one contains of the container, which is for the stateful set. We've got here some settings for liveness and readiness probes, and also for the resources. What I've encountered during the test was that the limits for the deployment of the operators are a bit small, so it crashed frequently. So what I'm going to do is I'm going to provide them more resources so that it gets more memory and also more CPU. So rough time for 4 times as much. And also, if you do a lot more testing of operators, what I would suggest is that you add here in the deployment or override the image pull policy of the operator. So for the operator deployment, that it's always pulling the new build operator and not using the later or the existing versions that exist on a cluster. So that can be a bit helpful. Okay, so we've updated the resources of the operator deployment, and let's now build our operator. And the command for that is make command. And sorry about that. The exact command is make docker build and docker push. So let's keep my fingers crossed that this is working. And as we can see here, the Docker build is running. It's getting the image signature, and now it's pushing that to Quay.io. So far, so good. Yay. Now comes the second part. We would like to deploy that. So we can see here, the command for that is not undeploy, but deploy. Come on. No. And we provide the image also which image should be deployed. So let's run that. And we can see what's happening is it's using customize. And after customize has been finished, we use kubectl apply to apply the configurations that we have. In case you say, hey, that's fine for me, I just want to provide a customer, or I don't want to use Operator Hub, I just want to provide a customer with a way how to install the operator, just leave that part with kubectl apply out, write it to a file and send that to a client, and then he should be able to install your operator. One thing that, well, a couple of things that you should notice here. First up, it's setting up namespace called Nginx stateful system. One, you remember that we provided as project name. We create the custom resource definition for Nginx webinar console. We create a service account, which is used to run the deployment. We define a couple of cluster roles and cluster role binding. We have a config map. And finally, we have the deployment. So far, so good. Let's have a look into our cluster. And for this one, I'm not using the OpenShift web UI. I'm going to use K9S because for this kind of examples, I find it a bit easier to use and a little bit more lightweight or faster. So as you can see here, I am listing all pods and all namespaces. We've got a new namespace called Nginx stateful system, and we've got a pod running here. Let's have a look. It's, describe. We can see that I just created it 2 minutes ago, and yeah, we don't see any errors, which is good. So we've got our operator running. So the next part would be, if we come back to that image, we need a CRD, which is controlling what the operator is doing, what it's deploying. So in our case, we will use the example, where's that? Here, and deploy that. But before I do that, let's have a quick look at it. So just do a cat and leave it out. So what this is doing, we've got, or what it's look like, we've got our API version, which is webinar console.de. The version is v1 alpha 1. Yeah, that's fine for us. It's a webinar, so alpha 1 is perfectly fine. and we define the name like in all Kubernetes resources, and we've got the specification, what should be deployed. In here, in my case, that's a copy of my values YAML. And this is how what will be used for deploying a new stateful set. One thing that I would like to mention as well is let's have a look at the cat configuration. There should be CRD, base, and we've got the YAML file. So let's have a look how the custom resource definition looks like, because it created it from the scratch. So it would be great if it's created at least a subset of it. But here I need to disappoint you what it's doing for the stateful for Helm is it just provides you with a basic setup. So we define that we've got an Nginx stateful set, how it works as a list, what the definition is for plural, singular, and also what the content of the custom resource will be. So here we define we've got metadata, which is an object. We've got spec, which is with a description, what it's doing, which is also an object. And also we tell Kubernetes whatever comes into that part, just keep it that way. Our operator knows how to handle that. And very similar with the status. And this is the part, if you work with operators here, you will do some work, or you need to do some work to create a CRD, which will have a meaningful descriptions and also which have some valid restrictions, what you can enter and what a customer or what a user can change. But enough of that, let's really deploy our custom resource and see what's happening in the cluster. So I deploy that, go back to K9S and see what's happening. So we've got here a namespace called Olaf, and we can see that already a pod has been installed or deployed of our Nginx application. So this is working. Let's have a look and see whether we've got also a route. So let's have a look at all the routes. And here we can see that we've got a route as well. Sorry, it's a bit hard to read. Let's see if we can call that route. So we've got the host name here. Copy. And so for the ones who are not familiar with OpenShift, OpenShift has routes, which are very similar to ingress resources of Kubernetes. Yeah, let's stay with that at the time being. So a route can be used for defining how you can access your application. So I use a curl, provide here the part of the URL and see what's happening. So I've got a message, or I get a status 200 back here, telling me everything is fine. And I've got a message, welcome to Nginx. Cool. So far, it works, looks like. Now, let me show you two things which make Helm operators a bit different than normal Helm charts. So here we can just search for the custom resource. I've got this one is called Nginx sample, and let's edit this one. So here we've got the replica count is set to 1. It's the easiest way to show you that something is updating is just modifying the replica count. So let's change that to 3, save it. Okay, this is working. Let's go back to the pods and let's have a look if this is really updated. So as we can see here, we've got our 3 pods now running instead of 1. Great, so this is working. And the other part, what I was explaining, that not only is the operator looking at the CR and see if there are some changes and apply that to the cluster, but the other way around is also working. So let's have a look. If we search, for example, for the services, from all services, we have here a service in the namespace Olaf for the engine export. So let's, oh, good, just delete that for fun and see what's happening. So I'm going to delete that and we wait a bit, and my hope would be that, yeah, here it's coming back. So the operator is not only checking this here custom resource, but also the way how it's deployed or applied to the cluster. So if something in the cluster is changing, it will make sure that will deploy the change or roll it back, so to say, to the definition how it should be. There are certain things that you can override as a user and certain things you can't override, but this is really depending on the way how the Helm chart is written. So far, that's the first demo that I wanted to show you. Let's go here and see whether there are some new questions. No, good. So let's start with a second demo. For this, let's go to the browser. Where is that? Yeah, here it is. So, yeah, sorry about that. Share. Okay, so this is my OpenShift cluster, and this is how it looks in ArgoCD. So I've got one application in ArgoCD, which is kind of a grouping all the Git repositories that will be considered watching for ArgoCD. So the repositories that it's using here is one on GitHub, which is called Helm webinar. So let's have a look at this one. So Helm webinar has a subfolder called GitOps, and it has also 3 other subfolders, which is example project 1, 2, 3. And in the example projects, you find a project setup, which defines the namespace definition. So here we've got setting up the example project 1. I've got a definition of a quota and RBUG setting. The reason why I've got here the quota definition and not only the RBUG settings is because I need a bit more memory or CPU for the Node.js application that I deployed. And this is the reason why I have to override that. If I can use the standard ways or the standard settings, like for example, for the limit range that you don't see here, you just don't need to provide that information. So here we've got a custom resource which will set up a project. Also in the same folder, there is another custom resource which is called OpenShift example. And this OpenShift example can be used or is used to install example applications. So here you've got the choice of 3 applications that you could install. I used in this test Node.js. So I just provide you just need to provide a parameter called enable. Do I want to have that? So no, I don't want to have Java. I don't want to have Rails. You can provide a name. So in case you want to override the application or the example name, you can just provide another name as well, and that's it. And I've done that for all 3 of the projects. I think the difference is that the project setup here is, let's have a look. Yeah, we don't install a sample application in project 2. So I assume that these are some advanced users which don't need sample applications. If we go back to ArgoCD and have a look at the detail what ArgoCD is deploying, we can see that it has 3 resources. So we've got the OpenShift example for version 1. This is going to be deployed in example 2. And we've got example 3, and we've got the example project 1, example project 2, and example project 3. The nice part is here that you can also see what's happening with the example application. So it's not only defining here that we've got the example, but you can also see what is created by the example operator. So we can see here that it has created deployment configuration for MongoDB. We've got an example for deployment configuration for the Node.js example. We've got 2 services, one for the MongoDB, one for the Node.js. We've got a secret probably for the MongoDB passwords and setup. We've got the build part for building the Node.js image. So everything is included here, and I just needed to provide the information. And if we look at OpenShift to see whether that really is the case, so we can go to the OpenShift web GUI. We see here that we've got 3 example projects. We can have a look at to see what's happening here. So no, I don't see the quota here. I'm going to show you that in a moment. We can see the workload. So we've got an overview of, come on, why does it take so long? To show you how the image would look like, how the application looks like. Sorry, that takes it. Okay, here we've got our Node application. Great, this works. And what I wanted to show you is we've got the role binding, and I don't want to see all the roles. I just want to see the roles in the namespace. So we can see here we've got 2 role bindings, which are assigning admin permissions to the user Olaf and also to the super duper admin, which also now has admin permissions. In that settings, we can have a look at the limit ranges. So we can see, yes, there is a limit range created, even if I haven't defined that in my CRD. And we can check that for all projects. So we can see, yes, we've got 3 limit ranges. So we tighten up that part. And also let's have a look at the quotas. So we have also 3 quotas for the namespaces. So we set up what storage and CPU they can maximum, or what they can use. So everything is set up. And basically this is what I wanted to show you. Let's go back to here to the demo part. Yeah, demo, I've done that. And coming to the summary, I hope you have seen that it's easy to create Helm operators or operators in general with the Operator SDK. Creating operators is easy. What's a bit more effort, or a lot more effort, is to test your operator with different configurations and also document how your operator is working. So the most effort what I've done so far was when I was using operators was really documentation of the custom resource definition, of the way how you can just deploy your operator. But this is not something which is only true for Helm charts. This is true for all operators. So even if you don't use the operator framework or the Operator SDK, that is always true. What I wanted to show you with the second demo was that the CRDs that are created for operators are used in GitOps or in other parts, just like normal resources in Kubernetes, and this is in OpenShift as well. So for ArgoCD, there is not a difference between setting up a project with the CR, or if we set up a deployment configuration that's still the same. If you want to know a bit more how the operator lifecycle manager works, how to set up the operator to do tests and so on, I've written a small, longer article about how to do that with a Helm operator, and you can find that here at that link. So with this, are there any questions?
First of all, thanks, Olaf. We're a little bit over time, and luckily there are no questions, so we will not go much over time. But no questions also means that nobody has used operators on autopilot yet, I guess, at least in this session. Too bad. Yeah. Maybe for further discussions in the future. So everybody, thanks for watching. Olaf, thanks for all the information. It was very detailed. And yeah, everybody, if you want to join us again with IBM, with, I guess, then Marion again, and not Sid, who's just filling in, but thanks a lot, Sid, for being here. On the 16th of September, we have a talk about Quarkus and remote development with Quarkus. And then we continue again with Quarkus, with messaging with Quarkus. After that, we will talk about operators a little bit more, and then operators with Ansible. Yes. So if you think about everything Olaf said and have questions in the future, we will see us again in like 2 months, and we will answer them then. All right.
Okay.
Then thanks everybody.
Thank you.
Have a nice day. Stay safe.
Bye-bye.